Let's look at the solution of geometry bites. If 6 solid cubes with edge 4 centimeter each can be placed inside a hollow cuboid whose two sides are more than 4 centimeter, such that no space is left inside the cuboid, what is the length of the longest rod that can be placed inside the cuboid? Hopefully you can see that the cuboid that gets created will look something like this. This is cube 1, this is cube 2, this is cube 3, this is cube 4, this is cube 5, this is cube 6. So one dimension is 8, another dimension is 12, and the height, the third dimension which is not visible, the height would be 4. So we have the 3 dimensions for the cuboid. When they're asking me for the longest rod that can be placed inside the cuboid, basically they're asking for what is the body length of the body diagonal. So length of the body diagonal is given by under root 4 square plus 8 square plus 12 square, which will be equal to 4 comes out normally. I have 1 square plus 2 square plus 3 square, which is equal to 4 under root 14, or the first option. Next question. 15 identical circles are arranged in a triangle shape as shown below in the given figure. Okay. If the height of the given figure is 10 centimeter, then find the radius of each circle. Okay. The interesting thing here to note is, if I join the centers of all the outer circles, can you see an equilateral triangle will get created? An equilateral triangle will get created. This is 2R, this is 2R, this is 2R, this is R, and this is R. So an equilateral triangle with side 8R, where R is the radius of one of the small circles. So the line here, and that goes here and here. It is R here, and height of the equilateral triangle. Height of the equilateral triangle is root 3 by 2 into side. Side is 8R plus 2R. One extra R here, one extra R here. This adds up to a total of 10. Okay. So this becomes 4. R would be equal to 10 by 4 root 3 plus 2. Okay, so R would be equal to 10 into 4 root 3 whole square is how much? 16 into 3, 48, 48 minus 4. So 45, no, sorry, 44 into bracket 4 root 3 minus 2. I can cancel out the 2's. This will become 5. This will become 22. The problem is places where I have 2 in the denominator. Oh, sorry, 22 in the denominator. Within brackets, the portion is not matching. So I would have to take 2 out common again. And I would be left with 5, 2 root 3 minus 1 by 11. The 2 from 4 root 3 and minus 2 goes, and from 22 also goes. We are left with this, which is indeed option D, and this will be the answer. Next one, PQRS is an isosceles trapezium that can be circumscribed about a circle of radius r units. If PQ is equal to 1 and QR is equal to 2 and PQ is parallel to RS, then find the value of R square in square units. Okay. So let's make a circle first. The trapezium will look something like this. The interesting thing to note here, this much we know. This is PQ, this is QR. Because it is an isosceles trapezium, QR and TS will be equal. We only have to figure out the length of SR. Now there is a beautiful insight. If a circle is inscribed within an even-sided polygon, the sum of the alternate sides is equal. Basically, here what we have is PQ plus SR will be equal to QR plus PS. This insight stems from simple idea. Let's say this point and this point and this point and this point. Let's name them M, N, O, P. Hopefully you can see. Sorry, M, N, O, Q, not Q. Q and P both are used up. Sorry. So I'm naming them A, B, C, and D. TA, if this is X, TD is also X because length of the tangent from an external point is equal. If this is Y, this is Y. If this is Z, this is Z. If this is W, this is W. Now see, PQ is X plus Y and SR is W plus Z. QR is Y plus Z and PS is X plus W. Both these groups are composed of the same constituent numbers, so of course they will be equal. So straight away, because PQ was 1 and QR was 2, you can straight away come to the conclusion SR is 3. SR is 3. Now if SR is 3, drop a perpendicular from Q to this point and drop a perpendicular from P to this point. Let me erase a lot of things. In order to get to that insight, I had to write far too many things than the diagram size would allow. Okay. So let's name these 2 points M and N. Now see, QR is 2. PQ and NM will be equal. PQ and NM would be equal because these are perpendicular lines that have been dropped. PQ and NM would be equal. So this is 1. And SN and MR would also be equal because this is an isosceles trapezium. So MR is 1. QR is 2. Can you see QM? QM will therefore be equal to root 3. QM is also the diameter. 2R is equal to root 3 or R is equal to root 3 by 2. Finally, what we need is R square. So R square will be equal to 3 by 4 or option C. Next question. In 3 distinct regular polygons, it is known that the measure of the internal angle of one regular polygon exceeds the measure of the internal angle of the other 2 regular polygons by 15 degrees and 27 degrees. Okay. So for polygon 1, internal angle would be X. For polygon 2, it would be X minus 15. For polygon 3, it would be X minus 27. Furthermore, the sum of the measure of the external angles, sum of the measure of the external angles of all the 3 regular polygons is 177 degrees. If internal angle is this, the external angle would be 180 minus X. 180 minus X minus 15, so plus 15, so 195 minus X. And here 180 minus X plus 27, so 207 minus X. And we've been told this adds up to 177. In algebraic terms, this would add up to 180, 180, 180, 540, 540 plus 42, so 582. 582 minus 3X is equal to 177. Okay, so 3X will be equal to 405 or X will be equal to 135. Again, now that I have 135, I can happily go external angle here would be 45, external angle here would be 60, and external angle here would be 72. I know sum of external angles of a regular or of any polygon. Sum of external angles of any polygon is equal to 360. So the number of sides can happily be identified as 360 by 45 equal to 8, 360 by 60 equal to 6, and 360 by 72 is equal to 5. So the final question, what is the sum of the number of sides of all the 3 regular polygons? This total adds up to 19, which will be the final answer. Last question. If the length and height of a cuboid are increased by 20% and 30% respectively, while its breadth gets reduced by 10%, then the volume will change by. Okay, fun thing. Can you see among the options listed, you can straight away mark C. You can straight away mark C because if you're increasing something by 20% and 30%, this has a cumulative impact of 56% increase. This has a cumulative impact of 56% increase. Even if you were to drop it by 10% now, you are definitely not reaching D or A. You're definitely not reaching. A or B are straight away out because you would need some more increase to get there. But after a 10% drop, it can only go up till here. Mathematically, if you want to check, let's say length, breadth, and height were 10, 10, and 10. New length has increased by 20%, so 12. Breadth has increased by 30%, so 13. Height has reduced by 10%, so 9. This multiplies to give me volume as 1000. This multiplies to give me 12 into 13 is 156. 1560 minus 156. So I'll get 1404. Hopefully now you can see the percentage change is 40.4. So the answer will be C. That is all for this set. Hopefully you learned something.